Hi guys. Today we are gonna look at the issue. Hi guys. Today we are gonna look. Yeah. I'm not using StreamYard too frequently. That's why we had that issue. Today we will look at deep learning for geospatial data with Ekrem Serdar Öztürk. And it's a niche area that you can learn a lot. And also for people who didn't join Global AI Hub yet or haven't heard of correlation program, today we will share some links about them, and you can check comment box and you can also ask your questions there, and don't be shy. So Ekrem, should we begin or maybe let's begin at maybe 6. How did you learn geospatial data?
How did I learn geospatial data? Okay. So I graduated from geomatics engineering in Yıldız Technical University. So while I was studying, we worked with various types of data, and one of them is actually most of the data that we worked with was geospatial data. And that was the first encounter.
So you just learn about it in the school, in the university?
Yeah. After that, I learned deep learning and convolutional networks, computer vision, and I just combined them together. And so, okay, there is a platform from that, and Global AI Hub, wanted me to do a workshop. And I think it's a very creative idea, and you can create lots of things, and you can do really good things with geospatial data and deep learning.
That's great. It's just interesting, and I think we can begin. Laters can come later. So
okay.
Yeah.
So we'll begin. Okay, just let me share my screen. So I think everybody see it. All right. All right. So hello everybody, and welcome. So before we begin, you can ask your questions. Hello, welcome. So as I said before, I'm a geomatics engineering graduate. So some of you are also studying geomatics engineering, and it's I think it's a good field to study, and you can combine it with machine learning and deep learning. And today we will focus on how we combine. Hi, Mohammed. Today we will look into how we can combine these two technologies, how we can combine geospatial data, also called spatial data, with deep learning. So let's begin a little bit. All right, before we begin, I'm Ekrem Serdar Öztürk. We will do 2 parts in this workshop. First, we will start with what geospatial data is, and then we will do an application of how we can detect detect after hurricane, how we can detect damaged buildings. So this will be our application, and you can find it in you can find the code in my GitHub, also in also Global AI Hub GitHubs. You can find the code in there, and also you can ask any question anytime from LinkedIn or also Instagram. So I'll just show the links here. You can also go back and check it out. Hi. Yeah, you're welcome. Yeah. So, said before, we will start with geospatial data, and we will get into with what is geospatial data, how we can collect geospatial data, how we can obtain geospatial data, and then we will combine deep learning with geospatial data. We will see what fields there, are, what application fields there are. So, and then we will check satellite image processing, and after that we will go to application. That will be the hurricane damage detection after I think Hurricane Harvey in 2017. There was a hurricane, and we will try to detect damaged buildings by using transfer learning and VGG16 model. I think everything's okay from there. So we begin with what is geospatial data. So first, okay, correct, everything's fine. All right, so I want to start with what is geospatial data. So I want to start with a question first. Have you ever planned a road trip or looked online for the closest pizza shop or post an Instagram story with your location linked? Then for sure you have worked with geospatial data. All right, if you haven't, I suggest you should. It's really useful. So geospatial data is also known as spatial data, as I said before, and it is used to describe data that represents features or objects on Earth's surface. All right. So whether it's man-made or natural, if it has anything to do with specific location on the globe on the surface of Earth, it's geospatial. All right. So geospatial data typically involves large sets of spatial data gleaned from many diverse sources in varying formats, and can include information such as census data or satellite imagery, weather data, I don't know, cell phone data, drone images, and social media data. Okay, that post that you linked the location, yeah, we can use that for as geospatial data. So geospatial data is most useful when it can be discovered or shared and analyzed and used in combination with traditional business data. So of course you have data and you have to analyze it. You have to create something from it and then use it to put it to application, right? So users can save spatial data in a variety of different formats, as I said before, as it can also contain more than location-specific data, like attributes. Sorry. So yeah, analyzing this data provides a better understanding of how each variable impacts individuals or communities or populations or companies, and etc. All right, so any questions here? Okay, no. All right, so I think everything's covered. So after this geospatial data, and we learned what is geospatial data, I want to move on to how we can analyze this data, okay? Geospatial analytics. So geospatial analytics uses data from all kinds of technology, like GPS, location sensors, again, social media, and mobile devices, and for sure, satellite imagery to build data visualizations for understanding and finding trends in complex relationships between people and places. So this georeference data can be applied to nearly any happening on Earth. Like the visualizations can include maps, graphs, or statistics, and cartograms that show historical changes and current shifts that can make predictions easier and more accurate. Okay. So geospatial analytics adds timing and location to traditional types of data, and this additional context allows for a more complete picture of events. And actually, insights that might have been lost in a massive spreadsheet are revealed in easy to recognize visual patterns and images. So like this image, okay, maybe you cannot understand what this image, but to create this, it requires maybe thousands of data in an Excel sheet, and this image shows a product movement analytics using geospatial data. So the red part is like, okay, this product goes here often, and the blue parts, okay, they're just less often parts. So geospatial analytics companies are able to instantly process huge amounts of data or geodata. This gives users the ability to interact with billions of mapped points while looking at real-time geospatial visualizations. And users can explore data across time and space to instantly see how something has changed from days to years, as this image. All right, no problems here. Okay. As this image, so this image shows the glacier mass changes in time. As you can see, the left part is September 2020, and the right part is March 2021. All right. So yeah, you can see the changes like varying, like ranging from maybe thousands of years and in a glance. So benefits of geospatial analytics include engaging insights, right? Engaging insights. So what do you mean by engaging insights? Seeing data in the context of a visual map makes it easier to understand how events are unfolding and how to react to those events. All right. For example, let's say the glaciers are getting disappears. That means, okay, we have to do something. Okay, we have to save the nature. Okay, so by showing the image, you can get I don't know, lots of feedback, better feedbacks. So the second one, better foresight. So better foresight means seeing how spatial conditions are changing in real time can help an organization better prepare for change and determine the future actions, right? So targeted solutions. All right, targeted solutions means seeing location-based data helps organizations understand why some locations and countries are more successful for business than others. Right? Maybe you want to buy some places. Okay, how do you choose where to buy? For example, a shop. Okay, you use geospatial data. You use geospatial data of the people and how they interconnect in some places. Then you should buy that place. So yeah, that's just a simple example. So it is possible to maintain spatial data or geospatial data as vector data or raster data. So first, raster data represents information presented in a pixel grid. So think about this as an image you take by taking from your mobile phone, right? So each pixel stored within a raster has value, like every image. This can be anything from a unit of measurement, color of information about a specific element. So typically, raster refers to imagery, but in spatial analysis, it often refers to the photos taken from aerial devices or satellites, because it's just spatial image. When you take your phone and take a picture, that doesn't actually count as a geospatial image. So the second one, vector data. So vectors are graphical representations of the real world. There are three main types of vector data, like point, lines, and polygons. So the points help create lines. Okay, so as you learned from the mathematics class, the line is a combination of limitless dots. So the points help create lines, and the connecting lines form enclosed areas or polygons. Vectors often represent the generalization of features or objects on the planet's surface. All right. So maybe you give some kid, okay, just paint this one. Okay, maybe a road, thing like that. How she or he draw the image. Okay, maybe they draw a line to define the road. Maybe put some dots to define the I don't know, trees, and yeah, that works like that. But also geospatial data, not only raster or vector, there is also something called an attribute, all right? Whenever spatial data contains additional information or non-spatial data, it is called attributes. So spatial data can have any number of attributes about a location. For example, this may be a map, photographs, historical information, or anything else that may be deemed necessary. Think about things like Google Maps. Okay, you search for a location and it gives you some photos, and those photos are attributes. Okay, let's check. Any questions here? All right, no. Okay, so I'll move on. All right, geospatial data challenges. So dealing with large geospatial data presents many challenges. Okay, for this reason, many organizations struggle to take full advantage of geospatial data, right? First, there is the sheer volume of geospatial data. For example, I don't know, it is estimated that 100 or 1,000 terabytes of weather-related data is generated like daily. So this alone presents considerable storage and access problems for most organizations, okay? As I said earlier, geospatial data is also stored across many different files, which makes it difficult to find the files that contain the data needed to solve your specific problem, right? Finally, working with raw geospatial data requires specialized knowledge and the application of advanced mathematics to conduct necessary tasks, such as geospatial alignment of data layers. Unless analysts are proficient and experienced at this work, they will not get value from the data or make progress toward their organization's business goals. So an example for this, the first thing, maybe geometrics engineering approved this one. First thing, when you use GIS applications, GIS applications, they tell you to, okay, check the reference system or coordinate reference system, check it, because otherwise, you know, the data that you put in the workplace, they cannot align. Yeah. So that needs information, that needs education. Yeah. So geographic information system. So we need, we have geospatial data, and we need a system for that, for analyzing or managing the data. So simply, a geographic information system is a system that creates, manages, analyzes, and maps all types of data. And as I said earlier, there are various of types that you can store your data, and you can only use it in a GIS work environment. Like there are two types of GIS, like, sorry, not two, one of the two examples are ArcGIS, maybe some of you know, and then QGIS, Quantum GIS. So they are the most popular ones. So, sorry. All right. Okay. All right, so a geographic information system is a system that creates, manages, analyzes, and maps all types of data. GIS connects data to a map by integrating location data with all types of descriptive information, like Google Maps or Yandex. Like they'll tell you where is an accident, or which road to choose while that accident happens, etc. This provides a foundation for mapping and analysis that is used in science and almost every industry. So simply, GIS helps user to understand patterns, relationships, and geographic context. So these benefits of GIS include improving communication and efficiency, as well as better management and decision making. And then we have well-known GIS applications such as GIS and ArcGIS. So there are 5 components of GIS. There are 5 components of geographic information system. So the first one is data. And methods, people, hardware, software, and you can see all these in here. All right, so I think they are all, thank you, Mohammed. So I think they're all self-explanatory, because to do geographic information systems, to work with it, you need data and you need methods to like calculations and unit methods like guidelines and other things. So you need people, of course. You need managers, GIS technicians. You need people to get the data, and hardware like printers or like you need some. For example, you need computer. So that's a hardware. Also software like GIS software to use GIS, of course. So they're also self-explanatory. All right. So how to collect geospatial data? How to collect geospatial data? So we've learned what is geospatial data and how we can analyze them. But how do we collect them? How do we obtain data? Any ideas you have? Maybe you can write it in the chat. Chat is a little bit quiet here. All right, okay, I'll just move on. You can write your answers there. All right, so one way to obtain, spatial data is by direct observation of relevant geographic phenomena. Okay, this can be done through ground-based field surveys, or by using remote sensors on satellites or aircraft. So many earth science disciplines have developed specific survey techniques, as ground-based approaches remain the most important source of reliable data in many cases. All right. So data that are captured directly from environments are called primary data. Okay, you go outside, you get the data. This is primary data. With primary data, the core concern in knowing their properties is to know how to process the parameters of any instruments used. Okay. In practice, it is not always feasible to obtain data by direct capture. Okay, think about a cliff, and you have to get the data from there. Okay, it's almost not possible. So factors of cost and available time may be a hindrance, and sometimes previous projects have acquired data that may fit a current project's purpose. So in contrast to direct methods of data capture, spatial data can also be sourced indirectly. This includes data derived by scanning existing printed maps, data digitalized from a satellite image, processed data purchased from data capture firms or international agencies, and so on. Yeah, everything can happen. Yeah, everything can count. So this type of data is known as secondary data. Secondary data are derived from existing sources and have been collected for other purposes, often not connected with the investigation at hand. So over the past 2 decades, spatial data have been collected in digital form at an increasing rate and stored in various databases by the individual producers for their own use and for sure commercial purposes. And more of these data are being shared among GIS users. There are several several reasons for this. Some data are freely available, but other data are only available commercially purposes. High quality data remain both costly and time consuming to collect and verify, as well as the fact that more and more GIS applications are looking at not just local, but national or even global processes. So new technologies have played a key role in an increasing availability of geospatial data. As a result of this increasing availability, we have to be more and more careful that the data we have collected are of sufficient quality to be used in analysis and decision making. All right. So as you can see here, you can use aerial like remote sensing. You can use drones or unmanned planes or other planes, also the satellites. Field survey, yeah. How long time will it take? All right. So I didn't get the question, sorry. How long time, the workshop or not? The workshop will be 1 hour. So deep learning and geospatial data. So now that we are covered on spatial data, let's check how we can use deep learning and geospatial data together. First, what is deep learning? So deep learning is a subset of machine learning and AI. It is machine learning algorithms with brain-like logical structure of algorithms called artificial neural networks. So difference between deep learning and ML, machine learning means computers learning from data using algorithms to perform a task without being explicitly programmed. But deep learning uses a complex structure of algorithms modeled on the human brain, like neurons. This enables the processing of unstructured data such as documents, images, and text. The latest technology to capture precise and accurate data over large areas from satellites, unmanned vehicles, and an aircraft has been utilization of artificial intelligence and computer vision. AI and machine learning models have great success in many applications, requiring large amounts of image data to aid in pattern recognition and create algorithms through computer systems. So where can we use this technological combination? First, we can use it for consumer insight. For example, to see when a place will be crowded or not. Therefore, we can come up with solutions like a I don't know, coffee shop. If it is most crowded on Saturday afternoon, maybe we can place our finest waiters. The second point could be risk assessment. So let's say after a hurricane, it is a lot of time and manpower to check which parts affected the most, because you have to be fast and help centers have resources need to be set up. And everywhere is in ruins. For this problem, you can build a model by fitting damaged and undamaged building applications. Actually, this is what we will do in application part. Before we begin to our application, let's check how we can process satellite images. All right, so satellite images processing is an important field in research and development. It consists of the images taken by artificial satellites So firstly, the photographs are taken in digital form and later are processed by the computers to extract the information, and statistical methods are applied to the digital images, and after processing, the various discrete surfaces are identified by analyzing the pixel values. So, sorry. And satellites take pictures, and they have lots of bands. Like an image taken by a mobile phone, they have RGB bands and much more like near infrared, as you can see in the image. Some satellites help us to see underneath of the trees, and some of them help us to take pictures during the nighttime. The satellite imagery is widely used to plan the infrastructure or to monitor the environmental conditions or to detect the responses of upcoming disasters. So mentioning of disasters, let's see how we can create a model by using geospatial data. So sorry, I have to stop the screen to go to the other share. All right. Share. Okay. So I hope you see my collab here. All right. So everything's fine. So any questions till here? I know it was a little bit boring, but I hope it was helpful. So you can find the data set that we will use to train our model. You can find it in my GitHub. You can ask me how you can obtain it. So try to do this project on your own because it's a really good project. Maybe you can put it on your portfolio or something. So try to do it, and please do not forget to share it because we want to see your results. Also share your results for sure, and please share it with me on your LinkedIn. Glad to be here. Yeah, thank you. All right. So before we begin, let's check. So okay, everything's fine. All right. So can you read the collab, or okay, just wait a second. Maybe I can just all right, make it bigger. All right, so I think this is better. Okay, so first code cell is used for accessing my drive because the data set is in my drive. Because also we are using Colab just because it has own GPU and it trains the model faster, so we use it. And you can also use it you only need a Google account, so you can do everything on your own. All right, so we need the first code cell for accessing the drive, and the second code cell is for importing our required libraries. All right, so we import OS library for directory applications like accessing the files. Also, the path, we also use this as well for accessing the files. And NumPy, Pandas, and Matplotlib. We use NumPy and Pandas to do calculations. Sorry. NumPy as well. NumPy, as you know, stands for numerical Python, and Pandas can be used for creating data frames and also creating data visualization. And Matplotlib, as the name suggests, it's plotting library, so you can plot, visualize your data. And then if you don't know what they are used for, you can also take our Python course in Global AI Hub. And if you feel like, okay, I don't know this, I don't know this code, what this code does, you can also ask me afterwards or also right now. So this code cell, what this code cell does, checks the files in our model file and these are the subset files. All right, so we have test another, train another, and validation another files. All right, so as I said earlier, all right, yeah, just give me a sec. Okay. Wait a second, I will drop the link there. Sorry. Okay, you can also find it in the Global AI Hub, GitHub. All right, you can find the same one, and you can follow there. All right, so let's continue. And I created a variable called input path. So if you write here your own path to the data set, this whole code will work the same. All right, so it's just for the efficiency. So we created a function called print file sizes, and we give it two parameters. First one, input path, we give our path here, and the second one, subset. So subset, what does this? We write here our subset name, like train another, validation another, we saw earlier here. So what this does, it gives the file sizes of our files, data files. Okay. So as you can see, it out like the output is train another, validation another, test another, and test. So the train another file has no damage file and damage file, and they include 5,000 files each. All right. So 5,000 files means sorry. Okay. Okay. Everything's fine. Right. So I hope you understand the function. I don't want to get into too detail. If you don't know what these do, please please check our Python courses in the Global AI Hub. After try to do this. All right. So yeah, the function gives us the sizes of the files, our data files. Okay, so now we use pandas. We imported pandas. Now we are using it. What do we use it for? We are creating a data frame, an image data frame. All right. So we use Glob. What this does is you give parameters like JPEG. All right. We want every JPEG file, and we want it to be our data frame. All right. So first one we created as path. We get the we get the JPEG file, and we give it a column, and every column, the path column has every image's paths. So after that, we create a damage column, and the damage column, what does it? What it does? It shows this picture is no damaged picture, and this goes like this, but there is also damaged picture. So damage column shows no damage and damaged ones. Data split show us the which file it belongs to, which file the image is from, and the location shows us the longitude and latitude names. Actually, these are the image names, so it's not that hard. And we also get the longitude and latitude from the name of our JPEGs, from the name of our images. All right, as you can see here, because we cannot see damaged ones, as we do value counts of the damage column, we can see 15,000 damaged ones and 8,000 no damaged ones. All right, so the files are in your drive. How can we have access to the files for practice? All right, I'll just share my data files in the GitHub. All right, I hope that works after this workshop. Okay, I don't want to waste time. So yeah, I hope that works. All right, sorry for that. All right, so this is our data frame. All right, we get every information that we need. We got longitudes and we got latitudes of these images, and we got where these images are from, and if they are damaged or non-damaged images. All right, so let's move on to the other one. All right, what we do here is first, we create a figure, all right? And we create a subplot. If you don't know this, please take the data visualization, okay? You already should know it. So we create different data frames by splitting train, validation, and test data sets. So how do we do it? We use fancy indexing. We use fancy indexing in our data frame here. So what do? We say image data frame. Okay, tag the train and other ones and assign it to the image df train. All right, and we do the same things over and over, and we create other data frames. All right, we just split them. All right, but when we split them, we also got indexes. For example, think about this one like damage. All right, so if we take this, we take this with the index 2, and then it doesn't do any good. All right, so first thing, we sort the values like for all of them. All right, and then we reset the index. So every one of the data frames start from the 0 and the how long it is. So we have reproducible data frames. All right. So we scatter the longitudes and the latitudes of these images. As you can see from here, so we plotted longitudes and latitudes of these images to show where are taken from. Okay, you can think this as a map. Okay, if you put this on a map, it still shows the where are the images are taken from. So, any questions still here? I hope not, because we just shows the data. All right. So again, we do the same, but this time we show damaged all images and non-damaged longitudes and latitudes. All right. How do we do this? First, we created a subplot with the 1 row and 3 columns, and figure size is 30 and 9. All right. So we want our first column to be image df damaged. All right, so we show the damaged ones here, and the second one is all images, like all of them. We scatter both of them actually, and the third one non-damaged. Okay, you can see here we take these from their own data frames. Okay, and the second one we plot the both of them. So we plotted the damaged all images and non-damaged. So damaged images are taken from this. Okay, you can see where are damaged, where are not. So all images like this, and non-damaged are like this. So as you can see, the hurricane affects this part the most. As you can see also in here, they're like bolder. So okay, I'm just checking. All right, not any questions. All right. All right, so let's continue. But before we continue, please fill the evaluation form, and that way we can improve our workshops in a way that you like. If you feel like, okay, this should be here or this should not, so maybe we can adjust ourselves like this. So please remember to fill it. You can find the link in the chat. All right, so before let's begin. So we import CV2. CV2 is a computer vision library. So first we read the path, we read the image by using our path in the image data frame, and we take the shape of it. So the shape of our image is 128, 128, and three channels, right? Three channels. What this means is RGB, right? But CV2 library read the image by BGR. Like think about the reverse it, right? So we have to do something for us. So we again created subplots with 4 rows and 10 columns. All right, as you can see here, we have 10 columns and 4 rows. All right, so what do we do here? We created 20 damaged ones and 20 non-damaged ones. Okay, just to show you how the images look like. So as you can see from the plot, damaged ones are actually really damaged, and non-damaged ones are just like ordinary neighborhood. So, but again, the thing with the BGR reading, we have to first convert our data, convert our image from BGR type to RGB. So how do we do this? We use convert color function and use image as parameter and convert color BRG to RGB, right? Because as I said before, CV2 reads the image as BGR, but ImShow, the plot, PyPlot, uses RGB. So we have to convert it. All right, you can see it here, but I zoomed it in by using this code of line. You can do the same and get the same result with 1 row and 2 columns. All right, and also use again the read. Okay, so it's not looking that good. I know that. First time I struggled a lot, but this is so this is a house, and this is the floated part. All right, this is actually water, and this is just a friendly neighborhood. All right. So anything till here? All right, everything's fine. Okay. So again, we showed the images, but the thing is, the hardest part for the model is this is not damaged, all right? This is just a house by the lake, okay? So we will see if the model gets the correct prediction or not. So right now we get histogram of the values of BGR values, okay, as you can see here. So before we begin, sorry. We will check for transfer learning, okay? What is transfer learning? Because we will do it, but before we do it, we have to learn it. All right. So transfer learning is transfer learning consists of taking features learned on one problem and leveraging them on a new similar problem. For instance, features from a model that has learned to identify raccoons may be useful to kickstart a model meant to identify tanukis. So tanukis are Japanese raccoons, all right? They are kind of the same. So in general, there are 2 types of transfer learning in context of deep learning via feature extraction and via fine-tuning, okay? So in this notebook, we are using fine-tuning method, so I'll just explain that one. So fine-tuning is removing the fully connected layers of an existing network. So you can think like this: input and output and fully connected layers in the middle part, and we take it out. We take out that part and placing a new set of fully connected layers on top of the network. Okay, and then fine-tune these weights and to recognize the new object classes. Okay. This technique is usually recommended when the training data set is large and very similar to the original data set that the pre-trained model was trained on. Okay, so we will see right now. So paths, we just got the paths and assign it to the train path, val path, and test path. And we do the label encoding. So label encoding, what is label encoding? We got damaged and non-damaged values, right? But the model doesn't work with the text. As I said earlier, it needs some values, some numerical values. So we changed the damaged ones in all labels. We changed the damage label as 1, okay? And the undamaged as 0. Sorry. So we slice them, all right, as you can see here. We just printed out paths. You can see the path here and label 1, okay? It's not saying, okay, this is damaged, but right now it is saying, okay, this is 1. 1 means damaged and 0 means non-damaged. Okay. So we use imread function. Actually, there is also a cv.imread function, but we created our own imread function to use TensorFlow. Okay, it returns RGB. It returns an RGB image and the label, as I said earlier, 1 and 0. Okay, so but before we give the image to our model, we have to clean that up. So we created another function, and that one is TensorFlow cleanup, TF cleanup, you can say that. And the parameter is image and the label. So we take our image and we convert it to a tensor, okay? And then we change the shape like 128, 128, and 3. Okay, and also we normalize it by because our pixel values are from 0 to 255, sorry, but we want them to be between 0 and 1. Because otherwise, if you want to take the square root of a pixel value, it will be huge. But if you take the square root of a value between 0 and 1, it will be easier for our model. Okay, so we convert it, and okay, we again resize our model. Image, and then label convert to tensor. Okay, we also convert our label to tensor, because we also convert our image to tensor. So again, this function returns image and label. So we use these functions with the map function. Okay, that was a little bit hard, sorry. Oops. I will just check if everything is understood in the chat. Okay, hello. Okay, so we use map function. So what map function does is it takes parameters and it applies that parameter. It takes a function as parameter and it applies that function to every row in the data set. So we use train data set and map. So we take these functions and created a new train data set. All right. So what we did is we created these functions and we applied the functions to all the rows in our data set. Okay, so as you can see here, we did the same. Okay, so let's say we have 100 images and we need to create a model, okay, train a model, and we need lots of images. So how do we do it? How do we do it? We do it by augmentation, image augmentation. So we're not creating a completely new houses. We just we rotate the image or crop it or change its rotation, some things like that. As you can see, we rotate the images, or we flip it, writing down like that. All right, and then we created kind of new. Okay, it's not new, but new data set. Okay. So we augmented train data set, all right? And of course, there are also new values to our data set. We have to combine these two with our first data set with the augmented data set. How do we do this? We use a concatenate function. With the trained data set, we concatenate augmented trained data set, and we do the same thing with validation data set. So we also renew the and train and valid and validation and test numbers, because we created a completely new data set. Okay. And we have to shuffle them. Okay, why we need to shuffle them? Because we don't want the augmented images to be in the same file with the like the same images. Okay, as I said earlier, we are not creating a completely new image. Okay, it is like the same image, but we crop it, we change it, we I don't know, zoom it, something like that. But if they are in the same file, it creates a problem. So we take one each and we just shuffle them. And by doing this, we use seed. So what seed does is, if you set seed as the certain number, like for example 6, and I have a list and you have the same list, we want to shuffle them, and if we set the same seed value, we get the same shuffle result. All right. So what seed does, it gets the same result every time. Okay? It helps you to get the same result every time. So we check how many values we get right now. So we train values, 20,000 train values, and validation, 4,000 validation. All right, so, sorry, check the image was read incorrectly. All right, so again, we checked our image shape because we set it like this, 128, 128, and 3 channels. All right, and label is 0 for that. Okay, so what do we do here? We created an image to show what is red channel, green channel, and blue channel look like. All right. So you can see here what everything look like, and when we combine them, they look like this. Okay. So you can guess what are the 1 and 0s. They're like, okay, this is the damaged one, and this is the undamaged one. So batch size, okay. The batch size is an important concept in deep learning. Think like this. Batch size is what batch size does is grouping the values. All right. So think like you have 60 values and you have batch size of 10. You are creating 6 groups of 10 values, correct? Because your batch size is 10. So again, we show the image batch by taking the train batches data set. So this is how it looks like. Because our batch size, it has 32 images of 128, 128, and RGB channels. All right. So we created a batch with 32 images, and these are the labels of those images, like, okay, the undamaged, 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 and so on. Okay, so we use fine tuning. All right. So as I said earlier, how do we use this? We take the middle part, neural network part, and we only use the predefined, pre-trained model. Okay. So how do we do this? We use VGG16. Okay, but the weights are coming from the ImageNet. So ImageNet is a database that includes lots of images like animals and other kinds of stuff. So it already has weights. Okay, so model works like this. Okay, before we begin, it says, okay, just assign random numbers as weights, and let's see how it works out. Okay. And then after the model works, it tries to reduce the loss function and change the weights. Okay, so we are thinking like this. Okay, this model can perform on specific data sets, but it already has weights. So why don't we use those weights, but change it a little bit, tune it a little bit, and use it for our purpose? Okay, this is transfer learning actually. So we use pre-trained model. Okay, we freeze the convolutional base, like the middle part. Okay, we are not making it trainable, right? We are just assigning the weights, okay, our weights. So we use image batch, okay, as you can see here. After the model, it returns a shape like this: 32, 4, 4, 5, 21. Okay, it changes the image shape by using convolution or other max pooling, some things like that. All right. So pre-trained model summary. Okay, we get here. Okay, we do convolutional max pooling, convolutional. Okay, these are what we did. What the model did to our batch, what the model did to our batch. Okay, like the group of images. As you can see, the output is 445. 512, as you can see here. All right, so we used the weights. Okay, we changed the weights. Right now we have a model for our data set. So what should we do? Now we are creating the middle part that we took it, the middle part that we took, and we are giving it a new neural network. All right, the new our part. So how do we do this? We are first giving it max pooling, average pooling. So, sorry. Yeah, the first, we are giving the first layer, the average layer, okay? So feature batch average. After this part, how it looks like 32 and 512, okay? Then we give it a second layer, all right, as you can see here. Now you can check the shape, it is 32, 1. Okay, so our model is constructed like this. You can use sequential. It says, okay, put this layer first and then other and then other. Okay, so we are using pre-trained model and we are giving it a global average layer as we set here. And then we give a prediction layer. It is here. All right. We give one output because the result will be 1 or 0. So it is either 1 or 0. It doesn't need two nodes. And we are creating model by using this. All right. So we set our learning rate and matrix as accuracy, and we are compiling our model. So summary, we got like this. We got like this, summary like this. All right. Okay, now we create our model. Now we have to train it. Okay, so sorry. Okay, we created initial epochs. Step per epoch. What is epoch is, as I said earlier, you have 60 images, 60 values. You created batch size, so your epoch is 6, right? Because you have 10 batch size, you are 6 group, okay? These are the groups. Epoch means group. So, okay, we are feeding our model by using validational data, validational steps, and train batches, all right? All the values that we set, actually, pre-processed, I may say. So you can see the validation accuracy of 0.8484. It is not that bad. And you can see the result of how our model worked. Here, you can see it. So accuracy was low. And after that, okay, it was a slope. All right, it goes up, and then it tries to find the optimal place. All right. So what do we now? We need to unfreeze the model's trainability. Then we train it with the actual, okay, with like actual model. So after we train it, we did just we do the same things again and again, all right? But this time with the real model, we get a validation accuracy of 96, 0.96. Okay, so as you can see here, when we evaluate with the test batch, we get accuracy of 0.94. So these are just for the predicting, okay? These are for you, you can do it and see the result of your own, and you can share it with us. Any questions still here? No, anything you want to ask? Thanks, but I got a 404. Why? The link to the materials doesn't work. I do again. Why is that? All right, let me send you another link. All right, any other question other than the link? Okay, maybe I can send it like this, then it will work. Yeah, you can also find it in the Global AI Hub here. Yeah, again, please don't forget to evaluate file, okay? Please give your feedbacks. Yeah, I think the problem is solved. If you try again, I think you won't get 404. So if someone can try again and tell what they get. Yep. Okay. Thank you. Thank you. Thank you for sharing that. All right. If you have any question about this workshop, please do not hesitate to ask. And please don't forget to apply our correlation program to benefit from exclusive opportunities like this. This is also I can tell like, okay, mid-level. If you want to go a higher level, okay, please keep following us. You can ask your questions in the Global AI Hub. Apart from the augmentation, did you use any tricks? No, I did not use any tricks. Actually, when I first saw it, I was surprised too, yeah. So if you have any question regarding these, you can always ask in the Global AI Hub. Also, you can ask me in private in LinkedIn, okay? But we guarantee you to answer your questions in Global AI Hub in 24 hours. So it's pretty cool, actually. And then you can also find us in here and my other colleagues. All right, so if none other questions, we can call it a day. Yeah, thank you for listening. All right, you can. I will also put a link in the data set. Yep. Again. Yeah. Okay. What makes you choose VGG16? Okay, thank you for asking that. Okay, so can the slide share with us? Okay, yeah. That also will be shared. All right. So what made me choose VGG16? So I also choose the Tectrons, but VGG16 is kind of like I like working with it. So it works best with the pixels, and actually that was the first try I did. If it wasn't that good, I would have changed it, but I got almost 0.94 accuracy on the test result, and after that, okay, yeah, that's enough for me. So yeah, I usually like using VGG16 because it works better with pixels, in my opinion. So yeah, not any like preferences or something. If it didn't perform that well, I would have changed it. So yeah, and I will share everything so you can find it in the materials, and also I will share the dataset link in the GitHub. So yeah. So if none other questions, we will call it a day. All right. Thank you for listening to me, and you can find the dataset in the GitHub, and you can create your own model. Maybe you can change it and show your results and share your results on LinkedIn, and we can see it. So that would make us very happy. So yeah, thank you for everything. Thank you for listening. Thank you, and bye. Have a nice night.